We're going to try something a bit different today. We're going to have a go at creating a emulation of one of these plugins that I've put on screen here, which is a Transient Designer or a Transient Master. This one's by Native Instruments that I've picked out here. This is a specific type of audio processor for changing the dynamics of an audio signal based on detection of transients in the audio file. Now, many people will be familiar with the concept of compression and gates and expanders. Those are they're dynamics processors, so they work on changing the amplitude of the audio signal at given times, and they are triggered by the volume of the audio signal. So when the volume of an audio signal goes over a certain level or drops below a certain level, something is triggered and some processing happens, whether that is to increase or to decrease the level of that volume, depending on what you're trying to do. That can be very useful when processing particular audio signals to increase their punchiness or to blend them more into the background signal. A transient designer or a transient master is a bit different. That is, instead of being triggered by the volume of an audio signal, it's triggered by the transient detection of transients within the audio signal. What are transients? Well, they're basically the onset of a note or the onset of a sound. And they can be, I would like to characterize them in this video as being when the slope of the audio signal is high. So down here at in the bit of the audio signal on the right where we're away from the transient, you can see these slopes are quite smooth. Over at the transient, you can see they're very sharp and jagged. So they have a high slope. They have a high coefficient, if you like. And what we need to do is we need to detect where that coefficient is. In order to do that, I'm going to use Gen, because Gen is going to be faster and easier for us in this environment. It's going to be a little bit more robust, a little bit more reliable for us, and it's going to allow us to do some things in a follow-up video where we can export our Transient Designer, Transient Master emulation as an audio unit or VST plugin using the new Rainbow environment in Max 8.5. So that's very exciting, because it means that those of us that don't work exclusively in Max, and I'm one of those people, can use our new Transient Master that we've made as an audio plugin in another DAW, in my case Logic Pro, but it'll work in whatever you want really. Okay, so let's get going. So I need an audio file that I'm going to treat, and the one I've chosen here is the inbuilt, I think this is inbuilt into Max. It's the Brushes drum audio file. Now, drums are particularly good for transient shaping because they have lots of transients in where the drums are being hit, so they're perfect for this kind of application. Its transient designers are not particularly useful on program material like strings or synths that don't have a sharp attack, because they don't have many transients to detect. Drums, of course, do have transients to detect, so they're absolutely perfect for this. So just to listen, this is the audio file that we'll be treating. I'm sure many people will be familiar with that one, so I hope so. Let's get going. So as I said, we're going to build this in Gen, and the first thing we want to do to work in Gen is to open one of these Gen tilde objects. I like to give it a name, I think a title actually, to start off with. If you don't do this at the start and you try and title it later, then you will lose the entire contents of your Gen object. So just be aware of that, because I have made that mistake far too many times to want to repeat it again. So we're going to call this Transient M for Transient Master. This gives us a Gen object with two inputs and one output. And if we go inside Gen, then you can see it's a bit like Max in Gen. It's got objects, it's got cables that connect them. They're not called objects in here, they're called operators, but basically it operates in the same way as Max, but rather than working at the signal vector level, which is taking chunks of audio and processing them piece by piece, like you know, like kind of one chunk after another in batches. It processes audio one sample at a time, which is very useful for being able to detect microscopic changes in the audio signal down at the level of the sample, which is what we want to do here. So this is the default that Gen gives you. It's simple. You can see what it's doing. It's two inputs that are being added together and are coming out the output. Now that's not particularly useful for what we want to do, so I'm going to get rid of a lot of this. We want to be working in stereo for this, so I'm going to, and the first thing I want to do is, because I want to detect transients in the audio file, I don't really want to be doing that I don't want to be doing the individual left and right channels independently, because then it'll process the left and right channels with transients differently, and it'll sound very odd. So much like a compressor will do, what I want to do is I want to sum together the left and the right audio signals in order to give me a combined signal, which I can then use for transient detection. So the way to do that in Gen is simply to add the two together. Now actually, what I want to do is, so I'll add the two together like this. This is a bit of a long-winded way of doing it. Now they'll be double in volume, so because each audio signal goes from -1 to +1 in range, that could in theory give me a signal that is -2 to +2 in range, which is too loud for processing, so I need to multiply those by 0.5. You notice I don't need the tilde next to these. I'm processing signals here, but I don't need the tilde next to the multiplication sign. That's because you're always working in signals in Gen, so you don't need it. Now this multiplication object isn't really needed, because what I can do is, just like in Max MSP, I can sum together the two left and rights at the input. So what's coming out of this yellow output here of this operator is the left and the right signals added together and then halved in volume to give me a combined left and right signal. And it's this that we're going to use as our detection signal for our transients. So how do we do that? Well, the first thing I want to do, as you saw in that picture, what I want to do is I want to detect, I want to be able to measure how steep the curve is on the audio signal. And so what I want to do, and so one way to do that is to measure the difference between one sample and the next. So if I take a sample in and it's at 0, and I take the next sample in and that's at 0.1, then that would give me a difference of 0.1. However, if the first sample is +1 and the next sample is -1, so that's a huge spike in the audio file between two samples, then that will give me a difference of 2 or -2. So there's actually an operator within Gen called delta. It's the difference between the current and the previous input. Now, input in this environment really means sample. So just to explain a bit more about what delta's doing, I've gone into Logic Pro and there's an audio file here. So if I zoom in on this audio file, you can see the individual samples here. And what delta does is it says at any given point, what's the amplitude of the signal at that point? So the height here, and the difference between that and the previous sample, which will be this one down here. What's the difference between the two? What's the delta between the two? And it outputs that as a value from that operator. So here it would be quite large, whereas over here, if I come over to the right a bit and pick two consecutive samples here that are closer together, then the output of delta would be quite small. So we can actually see that. So if I put an output here and then go back into Max, then over here, if I put the audios through here like this, and then let's put a live scope on the output like this and press play, you won't be able to hear this now. But what you can see is you can see something coming out here. Now this isn't audio. It won't sound very nice if you listen to it. This is a record of how steep the audio is at any given point. So you can see it's in there, and we should be able to measure these. So that's what we're going to do. So first of all, you can see it's dropping below the the center line here. So some of these are negative differences, and that's because sometimes the audio signal goes from a high value to a low value, so it'll give us a negative difference. Now that's fine. We can work with that, but just for ease, I'm going to use this, which is to give us an absolute value. So that basically says if it's a negative, make it a positive. So that means we'll always be working above this line. That makes it slightly easier to operate with. And you can see the transients here. This is a bit more easy to visualize. You can see the transients here, and we need to work with these. So what we want to do is we want to detect them. So how do we detect them? Well, what we want to say is we want to give a yes output, if you like, a 1, a true, if they're above a certain level, and a 0 if they're below a certain level. So there's an object for doing that, and I'll just insert it in here. Now I clicked on the cable and pressed Shift N to insert an object into the cable. And I want to say if the object is higher than a certain value, then you put something out, put a 1 out here, and if it's below a certain value, put a 0 out there, and that will basically give us a string of 1s and 0s where the 1s are where the transients are and the 0s are where they're not. So that's extremely helpful for what we want to do. So actually, to do this, we need to say what this value is. Now there's a number of different ways we can do this, but the best way in Max, I think, is to use parameters. So that what we want to think of is a parameter like threshold or sensitivity. So if the threshold is really, really high, then it's not going to detect many transients. If it's really, really low, it's going to. So let's give that a try. We'll create a parameter. Let's call it sensitivity. Let's get a default of, I don't know, 0.5. It should have a minimum value of 0 and a maximum value of 1. We can tweak all of these later. This parameter now should be available to Max back in here. So if I do attributes like you would normally do, oh look, sensitivity is in there, right? So we can now adjust this, and this should give us some value out when it's over. So let's try it. So you can see here, sensitivity 0.5, it's not giving us anything. I can adjust this down, and it starts giving us 1s where there is a transient. So this is extremely helpful for what we want to do. So you should be able to hear that drumming, and we should hear that now mapping. Yeah, so you can see these are now pushing out some trigger values here, some 1s on the audio file whenever it's over a certain value. So that's the start of what we want to do. So we need to do something with these 1s. Now I think that these, you can see there's quite a lot in here, and they're quite busy. So if we were to take this and then apply these values through some scaling to the audio signal, then we could reduce or increase the volume of the transients based on this signal here. So increase them by 0 when it's at 0, there's no transients. Increase it by an amount when there is a transient. But you can see here it's quite spiky, and it's a little bit messy. So we need to do some cleaning up. And the way we can clean up in Gen is there's a few things that we need to do. So one of the things that we need to do, which is this is a slightly easier side of things, is to give it some shape. So there's an object called slide, which is a bit like an attack and release envelope. So this basically says it slides between values according to how many samples you send, how many value into here, which is a bit like your attack time, like slide up time, and this is a bit like your release time, like slide down time. So this is going to be really helpful for us, because if we put this in here, and then we have some values in here and here, we should have a bit of an attack and release on these signals here. So actually, what we need is another couple of parameters. We need an attack parameter, which I'm going to say at the moment is 0, for by default minimum 0, and then let's say, what do you think, like maybe 500 milliseconds. And then we want a release time, similarly 500 milliseconds. Now you'll notice here that this is expecting samples, not milliseconds. because everything in Gen is working on samples. So we need to convert our 500 milliseconds time, or whatever it is, into samples. The best way to do that is with an MS to samps operator. The MS to samps operator is so useful because it will recalculate the itself based on the sample rate of your audio engine. So if you try and do this manually, then you'll need to work out what the sample rate is and multiply your number of milliseconds by number of samples per your sample rate, like 44.1 kilohertz or whatever. But if that changes, it'll go wrong. This means it's done for you. That's extremely helpful. So we'll put one of these on each of these, and then we'll put them straight into there. That should allow us, with another one of these little menu thingies, if I go into attack now, I should be able to change the attack time in milliseconds. Should be able to change the release time. Release time is going to be more helpful for us on drums. There we go, let's come up a bit. Now you can see this is going to be much more useful for us in terms of shaping the audio signal. Now we'll go back to attack, because I think on drums you don't really want soft attack. You want to be able to mess about with it a bit more. Alright. So that's giving us some transients there, which are going to be super useful for shaping the audio signal. But you can see there's a little bit of messiness still at the onset of each transient, because you notice on an audio, on most audio files, the spike goes up and down a little bit, so it'll detect multiple transients right at the start. Then it'll trigger a 1 to come out of this quite a lot, more than we actually need. So what I'd like to do is build a bit of a hold function, so it holds for a number of samples before dropping down to 0. So that's the next thing we're going to do, and that will allow us to smooth off the tops of these a little bit. So back into Gen. Now you have to bear with me a bit here, because this is a slightly complicated procedure, and it took me a little while to figure out exactly what I wanted to do here. So there's this accumulator operator in Gen, and what this does is it gets a signal in here, and it basically operates a bit like a counter object in Max, or a count tilde object in MSP, if anyone's used one of those. And it basically keeps counting from 0 up forever, but at the sample rate. So it's a ridiculously fast counter. And if I put another output here and stick this in here, and then give it a 1 signal. Now this is quite a fun little operator, isn't it? You can just send that. That'll send a perpetual. That's a bit like a sig tilde object with a 1. That'll just go into here. This should now be spitting out of our second output a number, and that number should be getting really, really high really quickly. So if I put a number tilde object on here and then put that in here, oh, look at this. You can see how high that's going and how quickly that's going. That's extremely helpful. Right. And what I want to do is I want to reset this every time this object gets a 1. So this is a bit like restarting a counter every time there's a 1, which is going to be very, very helpful for us in terms of a hold time function. So let's take this. So let's come. This is actually going to happen before our sort of ADSR thing. So I'm going to move this over here. So this should go into the right input, and the right input, when it takes any non-zero input into that right input, so that whenever we're getting a 1, when we get one of these triggers coming out because it's detected a transient, it'll reset this. So you should see this here, right? So every time there's a transient, this is resetting down to 0. It's probably hard to see because it's so fast. Because it's counting and it's resetting its counter, we can actually do an operation on this where we say anytime it's less than some input, some value, put out a 1, and whenever it's above that certain value, put out a 0, and that value is basically acting like a hold time. So it'll kick a 1 out when it receives an input in here, it'll keep counting and it'll keep putting ones out of here, a big stream of one, like a full one signal, until it reaches the value that goes in here, and then it'll put zeros out. So that'll give us a sort of square wave type effect, where the width of the square wave is equal to this hold time here. Now again, we need to convert our hold time into samples. I think a decent initial hold time of around 50 milliseconds is about right. We don't really need it to go above 200 milliseconds, but all of these you can be adjusted to taste. Let's get another parameter in there and call it and have it in there as hold. To 15 milliseconds. Now that hasn't affected this signal yet because we haven't done anything with this signal yet. But what I want to do is I want to say, so this one will give me all my spikes, and this one will give me my hold signals, but they should reset. So what I want to do is do like an operation where it's basically if there's a one coming out of here or there's a one coming out of here, then count it as a one overall. Now you can use an or operator for this. So it's actually extremely straightforward operator to use. You just say any of these coming in here, and that should be job done. So now we can see that there is a hold time, and I can increase that hold time, and that gives us a bit more sort of sensible stuff to go on, which is basically a bit more of an well, it's not an ADSR, it's like an AHR envelope that's triggered by the onset of each of these transients whenever it's around this sensitivity value here. That's the basis of it. Now that's fine because it's giving us this signal, but we need to do something with this signal now. And what I'd like to do with this signal is blend it with the other audio file. So that's the next step we're going to do now, is we're going to use this signal to scale this audio that's coming through here. So that's our next step. So this is basically the bones of our detection algorithm, which is quite useful. But now we need to actually do something with it. So because these are detection signals, I'm just going to leave these up here. And what we want to do is we need to do something down here with the audio signals themselves. So let's bring them back in. Just get rid of this a minute. These are our audio signals, and now because this is like an envelope out here coming out, we got the option of either increasing or decreasing the transient level based on choices that we want to make. So in order to sort of do that, I want to be able to blend this, multiply this by this. So the simplest way of doing this is saying this is my main audio signal, and anyone who's used MSP will be familiar with this. I'm just going to multiply it by that, right? Now that's basically as simple as it gets, okay? But I also want the option to multiply it by the inverse of that, because then that will allow me to reduce it. So in order to take the inverse, i.e. it's not quite the inverse, but it's actually it's one take away the signal of this. So it's like an upside down envelope. That should come in there like that. This gives me an option. So this will be like the transients completely boosted, or like only the transients, and this will be only not the transients. This is like a not operator. So this is only the transients coming out of here, and this is only the bits that aren't the transients. And we want to be able to choose between those two things. So let's mix them together. And then we can choose via here to blend between the two. So if you have this on 0.5, you should hear an unchanged audio file. If you have it on 0, you should only hear the transients. And if you have it on 1, you should only hear not the transients. And so that's almost like the focus of our signal. So I'm going to call this focus, and then we can use a parameter called focus to change that. So let's change that. Let's have parameter focus. It will be default to 0.5, which is basically off. It's minimum 0 and maximum 1, if I can type correctly. This parameter works a bit like a variable. So this picks it up over here no matter what we do. That's dealing with the left channel. We now need to deal with the right channel. So I just need to copy all this logic over here like that. And again, the left one is this left input of mix will be only the transients. This right input of the mix will be only the other bits that aren't the transients, and this how much of each, the blend of each of these will be controlled by this focus parameter over here. So we can now take these out, and we'll do out 1 and we'll do out 2, and that should give us a bit of a sense of what we've got here. Let's turn it up a bit. And now if we use one of these on focus, we should now be only getting the transients. Or if you go above 0.5, we're only getting the non-transients. So that's really fun. As I said, it's good to visualize these. So what I'd like to do is mix and choose and have a third output. You can even have a fourth output that is a blend of those signals. And then a couple of live gains, live scopes. One for our envelope. There. One for our audio file so you can see how it matches on. This one is not quite the right range, just needs to get between slightly more easy to visualize range. See what it's doing? So that's basically it. There are more things you can do with this, and we can do those at our leisure, really. You can use filters to filter the input signal to ignore bass. That makes it a bit easier for us to process the signal in here. I think that's quite helpful if you're working with things like electric guitar, where a lot of low ends can make it difficult for the thing to work properly. But that is our basis. So there we have a simple Transient Designer built in Gen. You can remove transients, all of them in fact, you can go all the way up. It's quite aggressive. Or just the transients. But of course there's a mixing tool that works best if you're just being quite subtle with it and you just want a bit of extra punch. Like that. Alright, hope that was useful. See you again soon.